Okay, so this is an optimization problem in calculus. Find two positive numbers whose product is 60 and for which the sum of 1 and 3 times the other is a minimum. Okay, what we are going to do here first is to represent. So representation. So let x be the first number and let y be the second number. Okay? Then we identify the constraint or the given condition in the problem. According to the problem, two positive numbers whose product is 60. So therefore, the product of x and y is 60. Then we solve for y because we need to express the function that we are going to formulate later in terms of a single variable. So therefore, y is equal to 60 over x. Then identify the quantity to be minimized since this is minimum. According to this, we need to minimize the sum. According to the problem, the sum, okay, so by the way, we have to formulate our optimization equation. And we need to minimize the sum. So the sum of the two numbers, the sum of 1, meaning the first number, which is x, and 3 times the other number is y. So 3 times the other. But we need to express as a single variable. So x plus 3, ry is 60 over x. So 60 over x. Then the function would be x plus 3 times 60, 180 over x. So to find the value that will give the minimum sum, we need to get the derivative. Okay? So we need to solve. Number 1, find s prime. Okay? Kukunin yung derivative ng function. So, we have s equals x plus, since this is 180 over x, here, we can make it as 180 x to the negative 1. Then, differentiate. Derivative ng x is 1. Then, 180 times negative 1, that's negative 180. X, negative 1 minus 1, negative 2. Or, 1 minus 180 over x squared. Okay? Then, next step, get the critical number. What will you do? We have to equate the first derivative to 0. So, 1 minus 180 over x squared equals 0. Multiply both sides by x squared. So, x squared times 1. X squared minus 180 equals 0. Transpose 180 to the right. Then get the square root. Plus minus square root of 180. And we know that 180 is 36 times 5. So, square root ng 36, 6, square root of 5. And since the problem is asking for the positive numbers, therefore we consider x equals positive 6 square root of 5. So this is our critical number that will be considered. Ngayon, we need to determine if this will give you a minimum sum. So using the third step under solution, use second derivative test. So therefore, we need to find the derivative of the first derivative. So the first derivative is 1 minus 180 x to the negative 2. Therefore, s double prime is the derivative of 1, 0. Derivative of negative 180 x to the negative 2, that's negative 2 times negative 180, positive 360 x to negative 3, or 360 over x cubed. Then we test the value of the second derivative at a given critical number. So we compute for s double prime of 6 square root of 5. That is 360 over 6 square root of 5 cube. As you can see, this positive, positive, very obvious that's greater than 0. No need to compute for that value. So since this is greater than value, we can conclude now that minimum sum occurs at x equals 6 square root of 5. So this would be the first number. So since x is the first number, so what would be the second number? Then the second number is y equals 60 over x. So therefore 60 over x is 6 square root of 5. So 60 divided 6, that's 10 over square root of 5. We rationalize, multiply by square root of 5 over square root of 5. 10 times square root of 5, 10 square root of 5. Then square root of 5 times square root of 5 is 5. Y equals 10 divided 5 to square root of 5. Okay, so therefore, the two numbers that would give the minimum sum are 6 square root of 5 plus, and 2 square root of 5. Okay? So that's how to solve optimization problem.